So my name is Jenny Lee, and I work for Closer as a developer trying to help in speeding up the workflow. So as Becky showed what's Archivist look like, I'm just trying to see if there's a better way or faster way to input everything into Archivist. My title will be Workflow Automation, so trying to automate parts, if not all the steps we do. So this is what's things already be inserted into Archivist. Then we can see everything on the screen very clearly. Where's the section, where the question, and where's the response to it. And the way we're trying to inserting everything, we have this build page, and then we go into it. We can have a code list, questions, and we can add things individually like this. So to add a code list, then we need to have a label, and we need to finishing typing everything, then click submitting button. And similar to the question item, we need to type everything in and find its response, then we can submit. So this involves a lot of clicking. And if it's a paper document, we use to just to typing everything in. And then we need to know which part of it is a question, or which sentence is actually a statement. So if it is a electronic one, like a PDF or XML or Word documents, then what we could try to do is to read in using a script. So I wrote a Python script trying to parsing everything. And then we can extract which part of the content is a question. So put them all together, and we put all the code lists together. Then we can bulk input everything into the Archivist database backend all together, rather than putting line by line like we used to do. And we also used this GitLab function. So it's a continuous integration. Which it does is to run a series of script, what you want to do. So in this case, then we have a pipeline for parsing. It's simple, just a Python script. And we also have a pipeline for inserting everything into Archivist. And there's also a pipeline for exporting. So there are many, many pipelines we have. At this stage, we can try to say which parser we want to use. And then we upload our document, then the pipeline will create a tables. Then we can use those tables, putting into the inserting Archivist pipeline. Then eventually we'll have everything in the pipeline. Then after this Archivist pipeline, we can see everything in Archivist. Then we can try to tidy up by either doing modification inside the Archivist itself, or we can changing our tables and then re-input everything again and see what is, if it looks better. So from a source code, we have a PDF, XML, a very general formatting. Then the parser will do is read it in and pick up all the questions, putting them all together, and then generate a table for that, and picking up all the code list. At the same time, we have some kind of relationship saying which code list belong to which question, and the position of it, where it belongs within a questionnaire. Then we output these individual tables. From here, the second step, we use the inserting pipeline. Again, this is we just upload all the tables, then we can have the final product via this automated GitLab CS script. And this is what it looks like on the GitLab page. So this is the example of the parser. We have a redcap formatted XML. Then we put it into the input directory. Then the parse Python script will parse it. Then we output all these tables. So the benefit of this is no one really need to download or install Python or all the libraries in your own machine, and we're building the machine on the cloud here. Then we run all the script inside those machines. So everybody will have the same environment here. And we can see after you run the CI pipeline, after finish run, you will go through a couple stages checking if the machine built correctly, if the parser parsed everything correctly. Then we have a download button. We can download the result. And the result will be all this code list, conditions, and question item, etc. All this in plain text file. Then we put all this into our inserting pipeline. So the pipeline has a couple stages at this time. Is first to check if everything in the input file looks okay, if they have a correct columns we need. Then we also check if they have duplicated question labels, if the question has a response, and all the statements should also have text in there. And gone through all this check stage, then we can upload all the tables into the database, temporary tables. Then from there, we're building the relationship from those temporary tables to see who belongs where. And finally, if every stage all gone correctly, then this study will appear inside the archivist, then we can look at it. And if everything is correctly the first time, but probably not, because so we do a lot of modifications, corrections at this point. And if everything's correctly, the pipeline will automatically export a XML of the questionnaire that we can put the actual one into our real archivist later. But this is just at the temporary playing stage. So this is the pipeline has stages, as I said. So first we check if everything quality controls inputting file all okay. And then if you build the database okay, if exporting the XML okay. So if every single one is green, then most likely you got everything correctly. Then we click on the download button, we can download the archivist tables where you put it in, and the XML file belong to the questionnaire itself. And another example of this trying to automate workflow is to do a check on the archivist itself. So from time to time, we're adding more new features or improvement into the archivist software itself, at which point it may break some other things that we didn't know it could, or we didn't know it breaking. So this time we used to have a very long list of things we want to check. So manually we do all this check by clicking buttons. So for example, we're adding a new question item. Will that works? Is still adding it or is breaking things? And same time, we want to see if everything else. So it's a very long list and we clicking through things. And now I use the Python library. It's called the Selenium. And this one is just allow the computer to control clicking through the web browser. In which case, then people will only need to see the results if this test fails or passed, rather than doing the clicking. So we have all this list of things that I currently can check. So we can create a sequence deleted, or we can add some construct into which branch we'll do. And all this is done manually before, and now it's just, again, running the script on the CI. Then it will produce a result, tell you which test fails. Then you can try to report it back to the archivist developer and say, which test I'm breaking, so can you please check? So as a summary of my talk is all this repetitive task that people used to do, like copy pasting or inserting line by line thing, can be done by computer in a better, more efficient way. And same time, we can free up people's time for higher level tasks, like actually look at the questionnaire and see which things make sense. And as my testing for the archviz itself. So currently I only have this many tests, but over time I can add more. I can always add more tests to the pipeline. So we can broaden up the coverage. Any questions so far?